I think we can start. The first slides will be a short presentation about me and about the company. Then, if someone is missing, they will join us later. Okay, so first of all, I hope that everything is fine with you with this global situation. We know that we are all struggling, but it seems that everything is turning. The situation is getting better, so I hope that all of you is okay and your companies are running fine. For the one who don't know me, I'm Marco Perreca, and I'm the sales area manager of the PM team. I work globally with our partners in order to supply to our customer technical service and sales service for our tightening solution, as well as the other products like air motors and surface treatment tools. FIAM, for the one who doesn't know us, is a 70 years old company, so it has few more years than me. We are 90. There are 90 employees. The company is really focused on the research and development and on the manufacturing, so the most of the employees are focused there. We have a global presence through our partners. As I told you, I call them partners and not the resellers or distributors, because they are involved in our processes as well. They provide together with us technical service in addition to just the sales. Okay. FIAM is present all over the world through these partners, as well as in France, Spain, and Italy. We work directly with our customers through a sales team. So we have also our employees in France and Spain. I would like to show you where we usually work. Okay, here you have some of our customers. We mentioned some of our customers and the main fields where we work in. I would like to say that the most important field for us, I mean, in terms of sales, of amount of sales, and as well on experience, are the household appliances, okay, as well as the general industry. Here you can recognize big names, as well in the electronic field especially. We are working a lot in this. We have been working a lot in this field in the past few years after the release of our new electric screwdrivers range. And another important sector for us are the automotive tires, where I think that the technology requirement, the technology demand is higher, and here they also push us to improve ourselves. Okay. Then going straight to the point, to the title of this webinar. Okay, we will basically, these are the topics that we'll address during the meeting. The efficiency of the production will be the key point, as well as the reduction of its cycle times. You know, when it comes to the cycles, the most important things are the improvements of the speeds and of the quality, so the reduction of the wastage and avoiding errors. In order to do this, we will see also some of the tools that are available in the market to prevent all the errors and to improve the process and its quality. we will see also, we will discuss also about the interconnectivity of this system with the factory. So all the data exchangement, the data management that there will be in the factories, mostly connected to the assembly, obviously. But I think that it's a really important topic, especially in this period. And at the end, we will see also that the KPIs that should be monitored in order to check if the process is running correctly and if there is something that can be improved. The cornerstones of the effectiveness of the production process are, as I told you earlier, the increase of the efficiency as well as the reduction of the lead time. There is another point that I think that is very important. I'm talking about the one-piece flow production. We called the flexibility like this, but basically we are talking about flexibility, especially in this period where all the companies started again after the corona disease and all the stops that we had. We started with high volumes and many different products should be assembled in the productions, and this could create problems. So we should find a way to be more flexible and adapt our production very fast in order to meet the demand of the customers. So going from one batch of products to the other in very fast and in an effective way, avoiding errors. Okay. The focus will be the in-process control. Obviously, to talk about in-process control, we should talk about also the post-process control, because we have to see also the differences. I would like to say that here we highlighted more or less the advantages that there are in the in-process control. And we will see later on also which are the KPIs that should be kept into account. First of all, the most important thing is in the in-process control, the most important advantage is intercepting all the faults, avoiding all the wastage. These keep the cost lower and also the lead time lower. As I told you, especially in this period where we are all running to meet the request of the customers, we have all the companies that I'm talking with in this period are running to meet to, let's say, ship all the orders in time, and it's not easy. Only just one error could cause a big delay in the whole production. So this is a really important point to avoid that this happens. Then another advantage of the in-process control is that it's much easier to meet the expectation and all the tolerances and the standards that our customers ask for. So the quality standards that the final customer, the end user that will use the product that you are assembling, ask for. Then there is also the real time. There is the real time of monitoring of these activities, and also the feedback that we give to the operator. The operator needs a feedback to make his job. Obviously, if he finds an error, he should find it straight away and then correct it. If he discover it later on, that would be a problem. So that's why an in-process control it's better, because you would avoid to waste time later on. And then all the information that are exchanged with the operator should be exchanged also with the rest of the factory. This is the basis for the interconnection between all the company devices, all the company tools. Talking about the process control and monitoring, I would like to to explain what we mean for monitoring or for control. Basically, the monitoring is the in-time control that we do. So it's checking what is happening and trace all these things. The control is a, let's say, wider view of the process control. So we will analyze the whole process, check all the data, and we'll try to improve this process. So let's say that with the monitoring, we just see if a problem occurs. With the control, we will avoid that these problems will occur. Okay, talking about tightening in the specific, with monitoring, we will make some real example. Okay, with monitoring, we will just check if we reach the torque, if the position is correct, and give a feedback to the operator. With the control, we avoid that the tightening is not made in the proper sequence. We set the correct program with the correct sequence, the correct torque, the correct angle, in order to avoid that a problem could occur. So the tightening monitoring, as I told you, we check if the torque control is on. We verify if everything was correct, so time, torque, and position were correct. And we also advise the operator that something happened. So if a problem appeared, okay. Then we talked about also POCA jockey system. I don't want to mention the name of the Japanese engineer because I don't want to be offensive with my pronunciation. But we're the father of this system is a Japanese engineer who used to work for Toyota and spend a lot of time in looking for a way to reduce and let's say turn to zero all the faults and all the errors that could occur during the production process. How he did this using devices and the systems in order to avoid that the operator could even make the mistake, and that's the point. Avoiding that something can occur, not just recognize the problem. It's working in a step before, so avoid that everything happens. So POCA jockey means stupid-proof, idiot-proof system, because the operator doesn't have to pay attention to the error to make a mistake. The mistake can't even happen. So that's the point. And talking about these POCA jockey devices, okay, they assist the operator, and you know, when it comes to the tightening cycles, I take the tightening cycle because it's the closest to me. But And also it's a very basic operation. But when you have a tightening, let's say every you have to tighten a screw every 5 seconds. Okay, at the end of the shift, it will be more or less, making the calculation, it will be more or less 5,000 screws for every shift. After an hour, let's say the operator is fresh and can pay attention to all the things that happen during the assembly process. But after 5, 6, 7 hours, when he's tired and he has done so many screws, so many tightenings, so many operations, you know, it's more difficult to pay attention to all the details. So we can't just put on him all the responsibility. He should be helped by system, by these POCA jockey systems. Okay. So here I would like to show you some examples. This, for instance, is a customer of ours that produce LED lamps. Okay, so for outdoor outdoor installations. As you can see here, there are numbers where you have to follow the sequence to tighten the screws, because here it should go a plexiglass that, if not tightened in the correct sequence with thermal variations, okay, temperature variations, it could crack. So it was very important to follow the sequence and that every screw was tightened correctly. What we did, we supplied to him tightening positioning monitoring. Basically, what does this do? The reaction arm check the position of the screwdriver. If the screwdriver is not in the correct position, it disables the ability of the operator to trigger the level and to tighten. So the operator has to follow the sequence, and it's not possible to make a mistake. So here there were no high requirements of torque accuracy, but the most important thing was that every screw was tightened correctly at the correct torque and in the correct sequence. And this system allowed them to avoid all the problems related to the temperature variation and to not following the correct sequence. I've talked about just one system which allowed the monitoring, but also prevent that problems occurs. We have other systems, also more advanced. Here, for instance, we have a socket program selector, which combined with a DC screwdriver or an electronic screwdriver, it's possible to automatically call the right program. So it means that the screwdriver select automatically how to tighten that component and the sequence that should be done. So this means that all the problems related to a mistake of the operator that could be tired, could be thinking about another process of the assembly. This system avoids that he could take the wrong screwdriver, tighten to the wrong torque. So this is very important. Also here we have the socket tray will light up the correct socket in order that the operator knows what to pick up. Then going to another example using these two devices. Okay, so the positioning control arm and the socket program selector combined with a transducerized tool, which allows you to reach higher accuracy. We supplied to a customer that, if I will remember, they do components for showers, okay? Anyhow, they needed to follow a sequence with an high accuracy and with two different torques, because basically there was a plastic component positioned on a stainless steel or on an aluminum plate. And the problem was that there were two different torques, and the torque needed a really high accuracy. So we supplied the positioning monitoring system to follow this sequence, okay? Then we supplied also the socket program selector in order to call the right program on the basis of the plate that there was here. The customer also asked us to have a full traceability of the process. What does it mean? That they wanted to store all the tightening data. And this is another example of storing the tightening data, communicating them, and having an high accuracy. Here we used a very advanced system in order to supply a really good accuracy, the correct accuracy. The customer asked for a plus minus 5%. The key point, the main requirement here was to have a complex tightening process, because there was a pre-assembly, so there was a positioning of the component, a pre-assembly, then there was another tightening to be done to an higher torque. If I remember, it was 5 Newton meter and 9 Newton meter. Anyhow, with an high accuracy. So here we needed a sequence of two programs, and storing all the information and combining them with the other information of the process and of the production process. Okay, then we discussed about, I talked to you about the transducerized tool, electronic tool, but what I mean for electronic tool, basically we have two different technologies. The first one is the transducerized tools. We call them torque and angle control, but actually the torque and angle control is done also with the other technology. The most important thing here is that there is a transducer which control what was the torque during the tightening, and also there is another sensor that detects the angle done, and this allows you to have a really good accuracy and to know exactly what happened during the tightening process. Then there is another solution, more, let's say, cost-effective, which is the current control solution. Also here, you can export all the data, you can control the angle, control the torque. It's just a different way to do these two activities. So basically, the torque is calculated by checking the current absorbed by the electric motor inside of the screwdriver. So this would allow you to have the torque data, and then there is another sensor. There is a real sensor that control the angle. So also here you can set different strategies, different program, and export all this information to the factory system, let's say, to the environment. Okay. We call them smart tools, but what we mean for smart, basically, as I told you, it's possible to set different parameters, so torque, angle, speed, the time, all the sequences. But another important feature is that with one screwdriver, as in the case that I told you earlier, whether we needed two different torques. With one single screwdriver, you can do more operation, more different components, when in the past, with a pneumatic screwdriver, you needed several tools. So this is a great advantage of these tools. Then setting different programs, it's really important, but what is really important is also selecting the right program and making the screwdriver interfacing with the PLC of the line, with the laptop of the line, and with all the devices connected to the system, okay, to the production system. Then we discussed about POCA jockey earlier, okay. Here, these tools are basically POCA jockey tools because they control the sequence, they count the screws, they set automatically the torque and the angle. So basically, here we have a real POCA jockey system that could be connected to other POCA jockey systems, as we showed earlier when we discussed about the tightening positioning system or the socket program selector. Then we discussed also about connecting with other devices, so about the interconnectivity. That is a really important thing that we will see later with the slides. Here we have all the controls that you can do with these smart tools, so with electronic tools. Basically, here we have all the torque control strategies, as it has always happened since there is this kind of control. The torque control is something really important, and is what the most of the companies are aiming for. With these kind of tools, we can combine this information with other information like the time, like the angle, and combine also these two parameters in order to see if everything is working correctly, and if everything is working correctly, and that the final result is what we are aiming for. But this kind of tools allows you also to have angle control or time control. So basing on these two parameters, we make the tightening. And this could be, for instance, be done to have a depth control, and or to tighten the screw to a certain point. That is something that is really important, and in some cases is the demand from the customer. Okay. Then they allow you also to tighten on critical joints, where an high accuracy, as I told you, combining the torque control with the angle informations will allow you to set advanced strategies to tighten on a very critical joint, on a very difficult material, tough materials, where in the past with just a pneumatic screwdriver wasn't easy to be done. It wasn't possible to achieve a good result, a good quality result that will last in time. And it allows you, these tools allows you also to make statistics and collecting all the information. And collecting the information is important to transmit them and analyze the processes, as we discussed earlier. Analyze the process is the start in order to achieve a better process, to improve the process, because with all the data we can analyze and understand where we can improve ourselves. This is the basis for the Industry 4.0, because here the Industry 4.0 promotes an environment where everything is connected, where all the information are traced, and basing on the big data, we will improve our processes and aiming for a faster lead time, for lower errors, lower wastage, and this is the real improvement that you will see by collecting the data. This is Industry 4.0 is a term that in the past year we've talked about so much. I think all the companies have talked about so much. I think that that for the future it will get more and more important to store all the information and to trace them and communicate them in a proper way. So this is what we call interconnectivity, and as I told you, the use of this data and the analysis is the most important thing. In addition to the human-machine interface, so also communicate all this information to the operator, to the people in the company in the proper way is the most important thing, to be effective in the communication between the system and the operator. Okay, so Inprocess and the post-process control, I would like to touch this topic, discuss about this topic, also related to the joint, to the real tightening. Okay, so the in-process control is something that that is done during the process, as the word itself says, and allows you to control that everything is working fine, and this measurement is not affected by external factors or something. Basically, we will see later, but there will be a transducer in between the screwdriver and the component. The post-process controls are typically require more effort if something occurs, because if you discover everything when you're doing tightening, it's much easier to correct. When everything is done and you check the quality and you do a post-process control, it's much more tough. And then here, this measurement is affected also by the skills of the operator. So the dynamic measurement is the in-process control that I talked about earlier. So basically, there is a transducer in between the screwdriver and the component. Then there is also the static measurement. Okay, here there are two ways of static measurement. Let's say the first one is a measurement on a joint simulator. So basically, the screwdriver is tested before using it on the components, on the real components, and here the accuracy is quite good, because there is a transducer. Is not demanded to the operator to have such high skills or something like that. But the point here is that you are not tightening on the component, so you're not taking into account many factors, and that's the problem. The other static control that can be done, this is the after process control that can be done, is with the dynamometric wrench, with the torque wrench. Here, what is the problem? Basically, when you make the wrench rotating, you will apply other torque. You will falsate, let's say, the measurement of the tightening. And there is also another factors here, another factor that affects this measurement, which is the relaxation of the material. Basically, after when you have let's say waves, gums, and where the joint is soft, there could be a material relaxation, and this could affect their measurement, because if you measure it straight after the process, you could find a torque information, where if you measure it after a minute, you could find another one. So that is a problem. So there are many factors that affect this kind of measurement. When you do the measurement with a transducer, a dynamic transducer, it's much more effective and reliable, let's say. Okay. Talking about accuracy, I think that it's very important also to mention some of the indicators that that should be watched when we talk about tightening. Okay, we have already spoke about this also in other webinars and also in our ebooks that will be available for you. We will show you the link later, and we will send you the link where you can download all this kind of information, so have more information concerning the tightening accuracy and all its indicators. But just to briefly show you what we are talking about, let's say make a distinction between two kinds of indicators. The first one is related to individual joints, so are based on a single joint, and there are also indicators that take into account more factors, so more joint and the variability also. So starting from these last ones, okay, we have the main shift and the combined mean torque and combined dispersion. What we are talking about here. Here, basically, we put in relation the data collected from the tightening on a soft joint and the data collected on a hard joint, and we see how far these two torque ranges are between each other, one from each other. The more these two outcomes are close, the more the screwdriver is accurate. Okay. Then we have the individual joint indicators. The first one is the dispersion, okay, and then it's histogram. Basically, the histogram is a representation of this dispersion. We will check how the tightening will be distributed in a range, okay, and we will check how these, let's say that here we could have different torque values, and we will see what will be the torque values that the screwdriver will provide. The closer this, and then we will put in relation this information with the value that we will measure during our test. So the dispersion is basically how it's the index that say how far is our tightening from what the screwdriver should supply, let's say. Then we also have the machine capability, the process capability, and the machine capability index. Basically, the machine capability is the factor that tells you if the screwdriver is making its job correctly. So it tells you if the machine performs correctly its job. This test is made in a laboratory, so that it doesn't keep into account all the variability that there could be, all the environmental factors that could affect the tightening. And it takes into account the requirements of the customer. So, for instance, I mean the tolerance that the customer wants with the performances of the screwdriver. Then a way to be more effective and look at the tightening process in the wall tightening process, so taking into account also all the external factor, is the process capability. So this indicator is made, this test is made directly in the production or with the components of the customer. It takes into account also the wear of the screwdriver, and this allows you to have a more precise indication of the accuracy of the screwdriver in your assembly process. So this is more, let's say, focused on the assembly process of the customer, of the assembly, on your assembly process. Then we have also the machine capability index. Let's say that if we talk about machine capability and machine capability index, the difference is that when the machine capability talk about repeatability, so it says to you that the screwdriver will apply always the same torque. The machine capability index will tell you that the screwdriver will apply always the same torque at the level that you require. So it means that if we have the histogram that we showed earlier with this information, if the customer asks for 10 Newton meter and you supply always 13, the screwdriver has a good repeatability, but is not accurate. When you supply always 10 Newton meter, you apply always 10 Newton meter to the component, and that is the target of the customer. There you would have an accuracy, and this information is given by the machine capability index. Okay. So basically, just to let you understand, this is it's not easy to draw it, but anyhow, the machine capability index will tell you how far these two torque values are far one from the other. So that's the point. Someone has a question and I have not well explained this, just ask it in the right chat and I will answer later. Then one point that I would like, one topic that I would like to address with you, the last point that I would like to address with you is this one. When we talk about accuracy, please pay attention. Pay attention to what they tell to you, because very often screwdriver manufacturers gives you information about the accuracy, telling you only the percentage of the accuracy, but they are not referring to any machine capability. What is the problem is that you don't know if the screwdriver is accurate or not, because you don't know if the screwdriver is working properly. As we discussed earlier, the CM indicates that that your screwdriver is working properly. So if you don't have 1.33, let's say, as a CM, or even higher, because maybe the requirement is higher. When we are in the automotive industry, probably they will ask for an higher CM, so they will need for higher repeatability. If they don't tell you to what the percentage that they communicate is related to what CM it is related to, it doesn't mean nothing, basically nothing. Here there is an example. They are an Italian company, but they are not an Italian company, sorry, it's in Italian, what is written here, but basically this supplier talks about a 5% accuracy. The problem is that they are not talking about the CM of the screwdriver. And that basically is the problem, because you don't know if the screwdriver is accurate or not. So you don't know if you will reach the result that you're looking for. So please pay attention to this. When it comes to the accuracy, if we refer to the CM of 1.33, talking about the different technologies, the technology that we saw earlier. So the transducerized tool has an accuracy, if well programmed, of from 1 to 3%. What I mean for well programmed, you know, when you have a car, and the car manufacturer can tell you that the car would stop in 50 meters, you know, but it stops at 50 meters only if you are going at 50 kilometers per hour, not at 100. The same thing here. You will achieve this accuracy only if the screwdriver is set correctly with the correct speed, the downshift, and all the advanced parameter that will allow you to achieve this result. If it's not accurate, the programmation is not accurate, it's impossible to achieve good results, even with the most advanced tool in the market. So this is a really important point. And the same thing is with current control tools, where the accuracy is slightly lower. Obviously, we are talking about different level of tools, but with current control, the accuracy is slightly lower. We are between 5 and 7%. Also here, it's very important, the programmation and the program that you set on the control unit. And at the end, we have the mechanical clutch screwdriver that they could be electric or air-driven. And here we have an accuracy of 10%. So I would like to thank you for the time you dedicated to me. Okay, here you have the link to our ebooks, where all the aspects that I talked about, I discussed about earlier, are mentioned and are well explained, probably better than I did. But I hope it has been useful, and it has been also a start to start looking for more information. And I hope you will have the chance also to read these ebooks that are really interesting. Then after this presentation, after this webinar, we will send you also a copy of the presentation, and you can click on the link much easier than now, let's say. Now, if you have some questions, please ask them in the right chat. If not, again, I would like to thank you so much for the patience and for the time you dedicated to me. Thank you, Nicola. Thank you, Gregorio, and Gregors as well. Okay, let's see. I see that someone is typing. Here you have all my contacts. Okay, so you can contact me for asking any question if it comes in mind after this. We will send you the electronic document, Gregorio. And yeah, just I was saying, there are all my contacts here. You can contact me also on LinkedIn. You can ask me all the questions that you would like, all the topics that you would like to address. We can discuss about them. Thank you. Thank you. Okay. Thanks for your time. Okay. Okay, guys. If there are no questions, I will close the webinar. Thank you again, and I hope to discuss with you very soon and to talk with you very soon. Okay. Thank you. Bye.